Today we're going to talk about how to install the TMC 2208 for the Easy type stepper by Big Tree Tech. We're going to install this on the Manta E3 EZ. So I need to talk about a couple of quick things right now. First of all, we have our stepper ports. We have our X stepper, our Y stepper, our Z stepper, our E0, and our E1, which is our first extruder and our second extruder. Now, obviously, with the TMC 2208 type stepper, we do not have sensorless homing, so we need to use an end stop. And there's an issue that I discovered on my board that hopefully is not on your board, but I'll show you a workaround for that problem. So the first thing that we need to know is where to install this and how. So obviously we don't have to worry about jumper configuration for this particular stepper on this particular configuration. So I'm just going to pick this up and show you that there's a little bolt right here, and that's going to face towards the power supply in this case. So I'm going to place it here and then push down to install it. So it's going to be on the X stepper, so I'm going to install this right here. Now, we don't need to worry about the jumpers, like I said, for sensorless homing, but we will need to figure out where our end stops are located. So the first thing that I want to do is I want to go over to the desktop of my computer and show you where those are located. So on my computer, you can see right here we have PC4 as our signal pin. If we trace this out, you can see that it comes up to here, and there's two pins that we need to worry about. Over in here, there's another stepper for E0 detect. That's usually used for excuse me, it's used for the filament detect. So let's first start with the PC4. So over on the actual desktop for the workbench that we're working on, we're going to need to attach the actual connection. And in this case, we have a red wire and a black wire. Red wire is going to be our signal wire. So I'm going to attach this right here and show you this real quick. So that is the configuration that we're going to start with, and we're going to check it. So I'm going to plug this in. It's going to take a moment to power up, obviously, but with the eMMC configuration right here, we have the actual drive on the board for the CM4 by Raspberry Pi. So this will boot significantly quicker. So let's go over to the actual computer desktop in a second and see what this looks like. So on the desktop, first of all, I want to point out that we have our Klipper install documentation. You can actually find your TMC stepper driver information right here. And in this case, we're going to use Stealth Chop. We're not going to use Spread Cycle. That is something that other people like to use. I prefer Stealth Chop because it allows us to step quietly when printing. This one is very noisy when things get moving. So we're going to have the Stealth Chop threshold at 999999 for our configuration in our stepper. But let's go over and see if this has come up. So I'm going to click on Machine Printer Config, and as you can see, we've got our stepper right here. This is not yet configured for the TMC 2208. So I'm going to scroll down and see if I can find it, which I will not be able to find for TMC 2208, as you can see right here. So this is what we're going to do to fake it out. We're going to copy this right here, then scroll up here. I'm going to hit enter a couple times so we can put this in the right place. Then I'm going to highlight this and then say Control / to remove the actual comments. Now, we don't use, in this case, the actual diag pin for sensorless homing, so I'm just going to delete this line. that's the configuration that we're going to use. Now we have to rename this to TMC 2208, and that's what we need for there. So there's going to be some other things that occur, but we're going to do a save and restart, and we're going to go over to the dashboard. And the first thing that I want to do is check our actual end stop. So I'm going to type M119 and press enter. Now you can see that it's open currently, so I'm going to show you what it looks like when we actually click it with our finger and do it again. So I'm going to up arrow, and as you can see it says triggered. So there's no issue at the moment. Originally I was seeing an issue with this, so it appears to have alleviated, but let's try doing M119 again, and it says open. So that original issue that I saw, originally what I did to work around the problem was to go to the next port over being the detection, the detection rate here for PC5, and all I would do would be to go into printer config and change this to PC5. Now we technically don't have an actual resistor sense here, so let me double check what that's called. That's actually for a pull-up resistor right here with that little caret symbol. So I'm going to take that out and retest it real quick here just to see if it comes out okay. So we're going to go back over to the dashboard, and on the dashboard what we're going to do is we're going to try this again with M119. So it's open, and I'll click it again, and it's triggered. So that makes no difference because there's no electronics on the actual end stop I'm using. So the next thing we need to do is actually test our actual homing. So to do that, we can't use home all because this will home 3 axes, and we don't have those. So we're going to home with the G code, which is G28 space X. If we were to leave off the X, it would be like home all. But I had to put my finger on the actual end stop right here, and then click it when it gets to the end of an axis. So as you can see, it does work. Let's see if it steps out now. So if we step out by 100, it doesn't work. So what you can see right here is if we look at the messages, there's no trigger on X after full movement. So there's a little bug here that we can work out with a simple line that we can put in here. And that's for homing underscore retract underscore dist colon space 0. So I'm going to put that in here real quick so we can see if we can fix this problem. So I'll place it right here, and then I'll do a save and restart. Then what I'll do is I'll go back to the dashboard, and I'll do the same command as soon as I center the axis over here. So now that we have the axis centered, I'm going to put my hand by the actual end stop, and I'm going to do the command that we did before by up arrowing and then hitting enter. So now that error is gone. Let's see if we can step out by 100. So that appears to work perfectly fine. Now if you do have an issue, I'm going to show you something real quick here. Normally what I do is if I'm having an issue because these are not up to date, I'll hit this little thing here that says check for updates, and then these will be highlighted as to what needs to be updated, and then I'll click on those to update as well. That should take care of most of the issues that you see. If not, there's obviously a Discord that I have that will allow you to ask questions of either myself or somebody else. And that will be in the description of the tutorial, as well as I have a Patreon link, as well as a PayPal link if you feel so inclined. So at this moment, I'm going to place a thank you note at the end of the tutorial to all the people that have donated. And also, I need to acknowledge that Big Tree Tech did provide the actual board for this tutorial being the Manta E3EZ. And I also want to point out a couple of quick things on the desktop, such as the power for this. We're obviously using board power down here, and then we're using motor power over in here. And that's actually in the, excuse me, let me bring it up here. In the actual pinout diagram or manual diagram, you can see right here that we have DC power in and then motor power. So that's where I got the answer for that. But let me show you it real quick here because obviously I didn't bring it up. So it's right here and here. So at this moment, I'd like to thank everyone taking the time to watch. Please like and subscribe, and I'll talk to you later.